Compound interest. When a bank pays interest, it is commonly added to the principal. The principal, having been increased, will attract more interest during the second interest-bearing period than the first. Let's just look at what this means. Let's suppose you invested $100 into an account giving 10% interest per annum. Now we looked at this with the simple interest example. You would get $10 interest in the first year. Now with simple interest you then continue to just get $10 interest because the interest is only paid on the amount you invested. With compound interest, these get added together. So in the second year when you get your 10%, it's actually going to be $11. So with compound interest, you get interest on the principal and on any previously earned interest. This continuing process of simple interest is called compound interest. The graph is exponential. So whereas we saw a linear graph with the simple interest, the interest goes up a little bit more every single time with this, and so you get bigger gaps, vertical gaps between each of the dots, and this builds into an exponential curve. Using the formula, the interest earned by investing a sum of money, the principal, is compound interest if each successive interest payment is added to the principal for the purpose of calculating the next interest payment. Now we looked at this slightly earlier with the $100 and the 10% interest. For example, if the principal P earns compound interest at the rate of R% per period, then after n periods the total amount accrued is given by A is equal to P 1 plus R to the T. That's when compounded annually, so you'll notice that n doesn't appear in the formula, but that's because for this one n is equal to 1. We just get one compounding per year. A is equal to P 1 plus R divided by n to the power nt when it's compounded n times per year. So if it's compounded quarterly, n would be 4 quarters in a year. Now, in these formulae, R is expressed as a decimal. R is often given to us as a percent. Remember, percent to decimal, divide by 100. This is how the formulae are written on the formula sheet that you're given, so you need to get used to using them. When plotted on a graph, the total amount accrued is seen to grow exponentially, and we looked at that slightly earlier in this lesson as well. The compound interest formula can also be written like this. Now if you use it like this, you put the R in as a percentage, and note that you've got the R over 100 here, which converts it to the decimal. A is the future value or final balance of the account. So A is a total amount here. That's very different to the simple interest formula, where the formula gives you the interest and then you have to add that to the principal to get the total amount. Here, with this formula, it gives you the total amount. So if you wanted to work out the interest, you would then have to subtract the principal from the total amount. P, as usual, is the principal amount. That's the amount that you invest initially. N is the number of compounding periods in 1 year. So if we compound quarterly, as we mentioned over here, n would be equal to 4. If you compound daily, then n would be 365. R is the yearly interest rate. Expressed as a percentage here, remember over here we need to express it as a decimal. And t is the number of years.